I'm going to go over the Chapter 10 mid-chapter test with you. This is for lessons 10.1 through 10.4. Number 1, what is the name of the longest chord in a circle? So first of all, a chord is any segment that goes from one end of a circle to the other end of a circle. The longest chord goes through the center of the circle, and that chord is called a diameter. Okay, so that's A. And you really shouldn't be answering C because we haven't learned what that is, and we haven't done that yet either. And the radius is not a chord because the radius goes from the center of a circle to one end of the circle. It only touches one end of a circle. It doesn't touch two ends of a circle. So that's number 1. Number 2, the radius of circle B is 4 centimeters. And the circumference of circle A is 20 pi centimeters. Find CD. The radius of circle B is 4 centimeters. So this little piece is 4 centimeters. And the circumference of circle A is, 20 pi. So if the circumference is 20 pi, and we know that any circumference is pi times diameter, therefore 20 and the diameter are the same. So if circle A has a 20 pi circumference, then I know that its diameter is 20. Okay, so here I have 20. This little piece is 4, therefore that little piece is also 4. And the question is to find CD, so that's the entire length. So that's just 20 plus 4 plus 4, so that's 28 centimeters. Number 3, a chord of circle P measures 8 inches. So I have circle P and a chord on circle P. Whoops. I don't want to erase that. A chord on circle P measures 8 inches. And the distance from the center to the chord is 3 inches. So that's 3 inches. Now remember, when you have a distance, that distance isn't only perpendicular, but it also is a bisector. So I know that this segment right here is chopping that 8 into 2 pieces. So I know that right here I have 4 and 4. Okay. All right, find the radius. Find the radius. So the radius I'm going to draw right here. And notice that I have created a right triangle. All right here. So I have 3, 4. It's a 3, 4 what right triangle? A 3, 4, 5. That's right. It's a 3, 4, 5 right triangle. And if you weren't sure about that, you could do Pythagorean theorem. 3 squared plus 4 squared equals x squared, and you'd get 5. So the correct answer is 5 inches. That's number 3. Number 4, if angle MON is 86 degrees, so that's 86, find measure of angle MPN, this one. Well, this right here, MON, is a central angle. Oh my goodness. It's a central angle, right? And if that's 86, the arc right here is also 86. And MPN, which is the angle we're looking for, is an inscribed angle. I just got this, so just playing around with the software. So it kind of looks like handwriting. So it's an inscribed angle. And remember, inscribed angles are always half of the arc that they intercept. Okay. So if the arc is 86, then half of 86 is 43. So that is the answer. 43. Number 5. Find x if measure of angle 1 is 2x plus 10 and measure of angle 2 is 3x minus 6. Angle 1 is here. Angle 1 is here. And notice that it intercepts this arc. Angle 2 is here. And notice that it intercepts the same arc. Since they intercept the same arc, they have to be the same angle because they are both inscribed angles. They intercept the same arc and they're both inscribed. So they're equal to each other. So that would be 2x plus 10 equals 3x minus 6. Solve for x. Add 6 to each side. X equals 16. Number 6. AE is a diameter of circle G and measure of angle BGE is 136 degrees. Find measure of arc AB. AE is a diameter, so let me see. AE is a diameter of circle G and angle BGE is 136. So right here, BGE is 136. And if that's 136, that's a central angle. I know that the arc is also 136. Find measure of arc AB. Well, if you take a look right here, from here to here, this is a 180-degree angle. So if a piece of it is 136, what's left of it is 180 minus 136. And that is 44. Number 7. A circle with radius of 12 inches has an arc that measures 8 pi inches. So, somewhere on this circle, we have an arc that measures 8 pi inches. Now remember, this 8 pi, this is a length. This radius is also a length. And we are looking for the central angle determined by this arc. That's this. X is degrees, okay? I just wrote X degrees, but you understand what I'm saying? So this is X degrees, so that has to do with 360, which is also degrees. So don't confuse length with degrees. So the first thing I'm going to do, the first thing you should always do with these is find the circumference. So that's what I'm going to do first. Now remember, circumference is length. So I'm going to do C equals pi times diameter. I always do this formula instead of the radius formula. I always go to pi times diameter. So that equals pi times, sorry about that. That equals pi times 24. because our radius is 12, so the diameter is 24. So that gives me 24 pi. So the piece is 8 pi. That's the piece. And this is the entire circle. That's the whole. And the x, this part, that's also the piece. And 360 degrees is the whole. So when I set up my proportion, I'm going to pay attention to all of that. So let's look at the two pieces. I mean, you could set up this proportion any which way. I think people usually like to compare length. So let's do length and length. So I have length of 8 pi versus length of 24 pi. This looks like a big mess. So I have length of 8 pi versus the entire whole thing, which is 24 pi. And that's going to equal to the angle piece, which is x, over the entire circle, which is 360 degrees. So you see how I set it up? 8 pi is a piece, 24 pi is the whole circle, and they're both lengths. And on the other side, we have x, which is a piece of the circle, x degrees, and 360, which is the whole circle. Now, before you cross multiply, there's a few things you can do. First, we don't need these pi's, they can go. And second of all, 8 divided by 24, that can be reduced. 8 goes into 8 once, 8 goes into 24 3 times. So I'm just going to reduce this whole thing into 1/3. So 1/3 equals x over 360. You can probably figure out from here what part of the circle out of 360 is 1/3. Or you can, if you can't figure out from this point, just cross multiply. 1 times 360 is 360, 3 times x, and then divide by 3. X equals 120 degrees. So that is the answer to number 7, 120 degrees. Sorry that this was a bit of a mess. I tried. I just got my computer, just got it, playing around with it. So I'll get better at it as we go. Come on, eraser, be good to me. I don't know what it's doing. Number 8. In circle P, chord AB measures 4x minus 6 centimeters, and chord CD measures 6x minus 12 centimeters. If AB and CD are each 4 centimeters from P, this is all centimeters, find AP. AP is this. So this is what we're looking for. Now, notice that what I drew is a right triangle. So in the end, you're going to be using this right triangle for something. But right now, you got to figure out, well, what's x and why did they give us all this other information? If you take a look, the two chords, A, B, and C, D, they have to be congruent because both of them are 4 centimeters away from the center. And remember, two chords that are the same distance from the center are congruent. So the first thing I'm going to do is set them equal to each other. 6x minus 12 equals 4x minus 6. Solve for x. So x equals 3. And if I plug 3 into either one of them, so if I'll take 4x minus 6, plug 3 in there, I'm going to get 6. So that means that AB, this whole thing, AB, is 6. Well, if AB is 6, half of it is 3. So I have a 3, 4, and what's the hypotenuse? It's a 3, 4, 5 right triangle. So the answer to 8 is 5 centimeters. Number 9, a 15-inch by 8-inch tablecloth is placed on a round or a circular table. So I'm just going to put 15 here and 8 here. Each of the 4 corners touch the edge of the table. So the 4 corners touch the edge of the table. I just messed that up. All right. Each of the 4, okay, I read that. Determine the radius of the table. So this is what we're looking for. Okay. Now, first thing I'm thinking of is I have a right triangle again. Here are my 2 sides, and the radius is a piece of the side. So I'm just going to extend it down, and I have an 8, 15 blank triangle. If you don't know this Pythagorean triple, you can always do 8 squared plus 15 squared equals x squared. You'll find that it's an 8, 15, 17 right triangle, which means that the entire length of the diameter is 17. But I'm only looking for the radius, so I have to take that 17 and divide it by 2. 17 divided by 2 is 8.5. And we're talking inches, so 8.5 inches. Number 10, quadrilateral ABCD is inscribed in circle P. Inscribed means that its vertices are touching the edges of the circle. That's what inscribed means. Find angle ABC. So we're looking for this angle right here, ABC. Let me erase that. So we're looking for this angle right here. I have 86 right here, 100 right here. And notice that this angle, this ABC angle right here, is inscribed in this arc right there. That's the rest of the circle that completes the 360. So 86 plus 100 is 186. And what completes the 360? 360 minus 186 equals, I don't know. I'm tired. I've been working all day long. I just don't know. 360 minus 186. 174. Oh my goodness. This is a brand new computer, so I'm just getting used to it. 174 degrees here. So that's not the answer to the question, though. Angle B is inscribed. Angle ABC is inscribed. And remember, inscribed angles are always half of the arc. So half of 174 is, again, I don't know, 80 something, 87. I'm very tired. So 87 is the answer to that question. I hope to see you guys soon. Really, this this one day of quarantine is already too much. So I hope you guys are doing well and taking care of yourselves.